Hey folks, this is going to be the first of several videos in section 6.4. And in section 6.3, we talked about vertical stretches and shrinks. We talked about horizontal stretches and shrinks, aka the amplitude and the period of our sine and our cosine graph. What we're going to be talking about in section 6.4 is horizontal and vertical translations, literally picking the graph up and shifting it up, down, right, and left. So what I've done for the first definition here for horizontal translations, I just wrote this a little bit differently. So I said that we're going to be moving to the right or to the left a distance of d, which is this right here. And all I'm going to say here is that we're going to go backwards from what's expected. So if you did this in a previous math course, back when we were shifting quadratics to the right and left, or the absolute value function, different parents, we were shifting right and left. And so the deal is if you had something like f of x minus 3, you would go 3 to the right. If you had f of x plus 3, you would go 3 to the left. So it's that kind of a concept. For vertical translations, we're just simply going to go up and down. If C is positive, we'll go up. If C is negative, we will go down. So we've got some further guidelines for sketching. This is a very similar gray box as what was in section 6.3. So you've already gone through a lot of this. Notice though that my equations have gotten much bigger. I now have C's and D's in my equations, whereas back in section 6.3, I only had A's and B's. So the first thing that you want to do is you simply want to find what your period is, which is 2 pi over b, and you want to mark the period on your graph. You want to divide into 4 equal parts, 4 equal intervals, and these are going to be your 5 x values, 5 major x values. And these are going to be either a maximum, a minimum, or x-intercepts. And then what you'll do after you get that, and this is all that we did in section 6.3 so far. Section 6.4, though, says once you have all of that on your graph, then decide whether you're going to shift up, down, right, and left. So you're going to use translations and take your 5 major values and just go right, left, up, or down. And then you'll draw. So let's go ahead. I'm going to do 2 examples in this video and then do the rest in a future video. All right, so as I look at my equation, and the first thing I see here is that my amplitude is 1. My period is 2 pi over b, so that's going to be 2 pi over 1, which is 2 pi. The inside here tells me that I'm going to have a horizontal translation. This can also be called a phase shift, P-H-A-S-E, phase shift. And so we're going to be going to the left, 3 pi over 4. And then my vertical translation, notice that nothing is being added or subtracted on the outside, so we don't have a vertical translation here. All right, so the first thing that we're going to do is we're only going to pay attention to the amplitude and the period. Ignore the shifts for right now and just pay attention to these 2 things, which is what we did in the previous section. So I'll mark off my, my 4 equal intervals. And sorry about that, I actually did not do that correctly. So here we go. Here's my 4 equal intervals. So I'm going to graph all the way out to 2 pi. Half of that is pi. Half of that is pi over 2. And then I can count 1 half, 2 halves, 3 halves, and 4 halves. All right, so this is a sine graph. So we're going to go up to 1 and down to -1. And we'll mark our 5 majors. So we've started at the origin. We have our maximum for the first quarter, back to the x-axis, our minimum, and then back to the x-axis. These are our 5 major values. Now what we're going to do is we're going to take our 5 major values and we need to shift them to the left 3 pi over 4. But before I do that, I have to figure out, well, how many blocks is 3 pi over 4 so that I know how many blocks to shift all of my points. So since I'm looking at pi over 4s, what I did was I took this first interval, the first quadrant, and I split it in half. I took half of a half and got pi over 4. And then I could just count. Every 3 blocks is another pi over 4. So you've got 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4 is pi, 5 pi over 4, 6 pi over 4 is 3 pi over 2, 7 pi over 4, and 8 pi over 4 is 2 pi. So then it's easy to answer the question, how many blocks is 3 pi over 4? Because of the way that I've drawn it, I have 9 blocks represents 3 pi over 4, 9 blocks. So that means that all 5 of my major values, I'm going to shift them to the left 9 spaces or 9 blocks. All right, so let's take our origin backwards 9 blocks. If you count, you only have 8 blocks, but I just added in a 9th block. And so when you start at 0 and you go backwards 3 pi over 4, that's going to land you at negative 3 pi over 4. And then I have my maximum. If I go back to the y-axis, this is only 6 blocks, so go 3 more blocks. And then let's take my x-intercept, my middle value, and go backwards 9 blocks. That's going to land me on pi over 4. And then I want to take my minimum backwards 9 blocks, and that's going to land me here. And then lastly, take your last x-intercept here and go backwards 9 blocks. And then you can connect the dots. These are your new 5 major values. And I've numbered almost all of them, except for this one right here, that first maximum, which occurs at negative pi over 4. So now every single one of my 5 major values is labeled, and that's my graph. Quick question, how does the graph of sine of x minus pi over 3 differ from the sine of x minus pi over 3? And what we would say here is this graph is the sine graph that moves to the right pi over 3. This one is the sine graph that moves down pi over 3. So that quantity is going to matter. All right, let's go ahead and do example number 2. So for example number 2, let's just take a look at what we have. Our amplitude is going to occur at 2. Remember that the negative out front tells me that I'm going to be reflecting over the x-axis. This right here tells me to move to the right pi over 3. And the period is going to be 2 pi over 1, which is 2 pi. All right, so the first thing that I'm going to work with is I'm going to work with the amplitude, I'm going to work with the reflection, and I'm going to work with the period. Those are the only 3 things that I'm going to work with. And at that point, then I will come back and work with shifting everything to the right pi over 3. All right, so if I go a distance of my 4 equal intervals here, I'm using each one as 4 blocks. The end of my period is 2 pi. Half of that is pi. Half of that is pi over 2. And then I can count 1 half, 2 halves, 3 halves, and 4 halves. This is a cosine graph. Cosine graphs normally start at the maximum, but because this one's reflected over the x-axis, we'll be starting at the minimum. So my max and my min values are going to be 2 and negative 2, so we'll start at the minimum. And not only that, but my ending value is also going to occur at the minimum. And I'm going to change this to an x. Sometimes I'll do like an x for all of my 5 original values and then a dot for my shifted values. It just kind of depends. The middle value is going to be a maximum. The 2 quarters are going to be x-intercepts. And so now I have my 5 major values, and I need to take each one of those and shift them to the right pi over 3. That's great, except for the fact that I don't have a pi over 3 marked on my graph. And so you can just pick a spot and call it pi over 3. Think about this this represents the first quadrant. And if you're thinking about the unit circle, pi over 3 is over halfway into the first quadrant. So what I'm going to do is I'm going to call 3 blocks pi over 3. Okay, so 3 blocks then is pi over 3. So that means that I'm going to take every one of my 5 major values and shift it 3 blocks to the right. So my first minimum shifts 3 blocks to the right. My pi over 2, 3 blocks to the right. My pi maximum, 3 blocks to the right. 3 pi over 2, x-intercept, 3 blocks to the right. And 2 pi minimum, 3 blocks to the right. All right, so we can go ahead here and draw our curve. A couple of things. I could use the unit circle because it's always going to be, if you'll notice here, it's always going to be one tick mark before the end of each quadrant. So you could use the unit circle to get your 5 major values. But I want to show you another way that you can get your major values. This method always works, although it's a little bit tedious. So a lot of times if you can count or you can use your unit circle, that's going to be a lot easier. But this method will always work. So I have my 5 major values listed here first. These are the original 5 values that I used. And since I'm going to move to the right pi over 3, then all I'm going to do is take each of those 5 major values and add pi over 3 to it. So 0 plus pi over 3 is pi over 3. Pi over 2 plus pi over 3. In your calculator, you can do 1/2 plus 1/3 and turn it into a fraction, and you can get 5 pi over 6. Pi plus pi over 3 is going to be 4 pi over 3. 3 pi over 2 plus pi over 3 will be 11 pi over 6. And then 2 pi plus pi over 3 will be 7 pi over 3. So then this is going to give me my 5 major values. So this guy here is going to be 5 pi over 6. And the one right before 3 pi over 2 will be 4 pi over 3. And the one before 2 pi will be 11 pi over 6. And then last but not least, this guy here is going to be 7 pi over 3. Okay, so I'm going to, at this point, stop the video and then come back for a few more examples.